Here's the Hamilton-Standard Counterweight propeller on the T6 Texan. So it's a constant speed propeller. So we'll start at the governor, which is that thing right there. So basically, if the engine's not spinning fast enough for the selected RPM, set by that little linkage right there, it sets the spring pressure on the flyweights and the pilot valve and all that. If it's not spinning fast enough, what it'll do is, so as I mentioned, you want to use oil pressure. Ideally, you want to use oil pressure to move the blades towards the unfeathered position, or the low pitch position, or the high RPM position. Kind of confusing: low pitch, high RPM, high pitch, low RPM. High pitch is towards feather, low pitch is towards unfeather. But this is a single engine airplane. It's not appropriate to say feather and unfeather. It's a multi-engine thing. So anyways, so if the engine's not spinning fast enough, the governor will send oil into the piston right here, which will move the cam right here. So imagine this piston extends out, it'll move this cam out through this, and it'll cause this blade to go like that, so it bites less air and it spins faster. So now it's spinning too fast, let's say. Well, it got on speed now, but let's say now it's spinning too fast. So the governor is going to divert less oil pressure to the piston. So what happens when you divert less oil pressure? Well, if you remember, there's two forces that act on the propeller blades. There's the aerodynamic twisting force. The aerodynamic twisting force is because the center of lift of the propeller is approximately right here. And what that wants to do is it wants to move the blade to the flat position. However, that force is counteracted by the centrifugal twisting moment. And to explain that, you have to think of centrifugal force. It wants to make everything go like that. So imagine a line right here. And so centrifugal force wants everything to move out away from the center. So it can either move that way, or if something moved this way, wouldn't it be moving further away from the center if it was forced to go this way? Let's say it was only confined to this direction. So if something, centrifugal force would want it to go whichever way, that would make it further away from the center, if that makes sense. So what I'm trying to say is, maybe that helps picture better why the blade wants to go like that. It wants to fly out from a centrifugal force. Even though centrifugal force is going that way, it doesn't seem very intuitive until you think of how it will want to make everything fly out away from center, even if it means going this way. Because if it's going this way, its distance from the center is actually increasing. Because if it was going the same distance from the center, it would be going this way. See, that it would be a curve, but hopefully that makes sense. The centrifugal twisting moment wants to make the blades turn flat, and that is bigger than the aerodynamic twisting force, and without any kind of pressure, that's what these blades would be doing. So that is counteracted by these counterweights. So you see, the counterweights work at the same principle. The counterweights will want to, again, you can see they want to go this way and that way. When the propeller's spinning, it'll want to be as far away from the center as possible, and it'll want to go this way, but it can't do that. It can only go this way. And it'll want to go that way, which will make the propeller spin like that. It'll want to turn the propeller flat. So the counterweights here want to oppose the normal centrifugal twisting moment of the blades, and it'll make the blades want to go flat. And so when the oil pressure is removed from the piston, it'll make the blades go flat. And Matt's here. Alright, back to regular scheduled programming. So as I was explaining, when the oil pressure is drained, there's no longer anything pushing this way, opposing the force of the counterweights. And now the counterweights flying out, going that way, will want to make this piston So yeah, I kind of thought about it too. So yeah, these counterweights will go out, but in the fine pitch position with the blades fine, high RPM, unfeather, the piston will be out and these counterweights will actually be further up. When the oil pressure is drained from this piston, these counterweights will start going down to where they are right now. Because if you kind of look at this track, it will be retracted like that, and then the piston will retract. And this is actually the high pitch position, the low RPM, unfeathered feather, what would be feather on a multi-engine airplane position. So yeah, hopefully that word salad I explained makes sense, but essentially these propellers use a different variety of means to do what they need to do, and primarily, you've got the centrifugal twisting moment to counteract, and this airplane does it with counterweights. So if there's a balancing force between these counterweights that counter the centrifugal twisting moment, and now, so you've got oil pressure going one way and the counterweights going the other way. So oil pressure, counterweights, oil pressure, counterweights. But this is an old way of doing it. Some other propellers use a spring. I believe that's what the PT6 uses. And some others use something else. I'll talk about it very soon.